Hi! Exploring the Plane posted a video yesterday in which he observed some mountains in Northern Ireland from a place in Wales. As is tradition, he claims this observation is impossible on a globe, so let's take a look. This is the observation. Exploring the Plane claims that only the parts of the mountains above the red line should be visible on a globe. Why? Here's the problem, and it's something that has been happening a lot. He used a curvature calculator that doesn't include refraction. This means that the hidden value he got is a value for a globe without atmosphere. The mismatch can thus be understood to mean that we don't live on a globe without an atmosphere, and this is a conclusion I can agree with. Unfortunately, it doesn't follow that we don't live on a globe at all. I've tried recreating the observation in my simulator with refraction turned off, and sure enough, just like Exploring the Plane claimed, much less should be visible. Still, it's a bit more than he claimed. If we decrease the opacity here, we can see that the horizon in the simulation is below the red line that he drew. I guess this might be due to different distances to different mountains, resulting in different hidden heights, but overall it is still close to his predictions. Let's see what happens if we include standard refraction. Here is a simulation with light being affected by the standard atmosphere. As we can see, a much larger part of the mountains is visible, and this is pretty close to what Exploring the Plane recorded, but it's still not quite there. In his observation, we can clearly see this thin black sliver of land on the horizon, which is not there in the simulation. So does that mean the globe is busted? Well, not yet. Weather conditions change, and close to the surface the refraction is often non-standard. So let's try to figure out what the actual conditions could have been. I've asked Exploring the Plane about the date and time of the observation. He has been kind enough to provide the information, so I'm grateful for that. As a side note, my response to him, which you can see here, is invisible under his video. I don't know if he banned me or if it's YouTube acting up again. If it's the latter, Exploring the Plane, if you're watching this, as you can see, I did try to respond. Feel free to continue the conversation here under my video as long as YouTube allows. Now that we have the date and time, we can go look for the atmospheric data. Here's a website that has some useful sounding data. Unfortunately, there are no stations along the line of sight during the observation, so we won't be able to get the proper data. The closest station is this one, in Northern Ireland, Castor Bay. Let's try it. After searching for the interval between 16th of July, 12 o'clock Zulu, and 17th of July, midnight Zulu, we only get the data for midnight 17th of July. There is no data for 12, unfortunately, so the only dataset we can use is the one from midnight. If this data is entered into my simulator, the resulting view is this. As you can see, more of the mountains are visible and they seem to be distorted a bit, but still no sliver of land between them. Still, remember that the station is quite far from the line of sight. If the conditions along the line of sight were different, we'd expect a different view. I decided to do a small test and simulate a thin inversion layer over the water, isothermal layer above that, and then standard gradient above that. You can see the comparison of the temperature profiles here. The smoother purple line is the data from Castor Bay from 17th of July 2021 at midnight. The other line, the green one, is the profile I decided to test. So, how did it do? As you can see here, it did quite well. We actually got the thin sliver of land that was visible in the actual observation. The thin inversion layer supplies conditions required for the light to bend slightly more than usual, and thanks to that, some lower parts of the mountains are loomed more than usual and compressed, creating this image of some land on the horizon. We can see in this overlaid image that it's actually a really good match. At least much better than standard refraction. And what about the flat Earth? Well, on a flat Earth nothing should be obscured, so if we simulate that, we get this. What Exploring the Plane recorded definitely looks nothing like flat Earth. And one small bonus for the end. Before Exploring the Plane told me the date and time of the observation, I generated some simulations with very recent data from Castor Bay. This one is with the data from the 6th of March 2022. And as you can see, it got pretty crazy. That's not to say that if Exploring the Plane went to make an observation on the 6th of March, he'd see this. I remind you that the data was collected over Castor Bay, which is some distance away from the line of sight. Still, it shows what weird effects realistic temperature gradients can have on the view. This is something that could happen under the right conditions. under conditions that actually happen somewhere, which only shows how important it is to take refraction into account. That's it for today, thanks for watching and see you in the next one.